So now let's do one that's a little bit harder. This is going to be one where we have to complete the square. I have a video on that if you want to watch it. I'll have a link here somewhere. I don't know, you can click it if you want. So, what we want is we want this to be in a perfect square. But you can tell that nothing's gonna multiply to get 5 that adds up to get 4. So what we're gonna have to do is complete the square. So, the way I like to complete the square is I like to take this middle number, divide it by 2, so 4 divided by 2 equals 2, and then I like to square that number, because that's going to be what it is times itself, which is going to be this number. So that's going to be 2 squared equals 4. The video I have on completing the square is a little bit different, but I find this one easier because there's no blanks you have to fill in. It's a little bit easier to handle. So what we can do is we can rewrite this as x squared plus 4x plus 4 plus 1, right? So what we're trying to do is we can write this in parentheses, because this is going to be a perfect square. It's going to be x plus 2 squared, right? We can leave this 1 out here because we know that 5 and 4x, they're not going to have a perfect square. We can just push it out there. We don't want that 1. Goodbye 1. You're not wanted here, right? So this is going to be x plus 2 squared plus 1. Let me, forgot about that 1. Okay. This is going to be 1 over x plus 2 squared plus 1. Integral of that. Right? So, which one of these seems like the proper one to use for here? Tangent, right? It's the only one that has addition in it, and it's the only one that doesn't have a square root, and we can talk about how you can do that, right? It's fairly easy. Nothing to worry about, right? Okay, so what our x is in this problem is x plus 2. Notice it's not just x here. It can't be x plus 2, it can be x squared, it can be whatever you want. And our a is 1. So let's rewrite this. X equals x plus 2 equals tangent of theta. Okay? So, when we're going to find our derivative, dx equals secant squared theta. Now, we're going to set up our triangle. So, tangent is opposite over adjacent, and we have x plus 2 over 1. Opposite is over here, x plus 2, and this is going to be 1. So this is going to be the square root of x plus 2 squared plus 1, right? Now we're going to use our little buddy here, secant of theta, and we're going to solve for him. So in that previous problem, we figured out that if cosine of theta is adjacent over hypotenuse, and secant is 1 over cosine theta, that means that secant is going to be hypotenuse over adjacent. So the hypotenuse, x plus 2 squared plus 1, over the adjacent one, that's 1, so we don't even need to write it. And so here, we're going to want to square both sides, right? Because on the bottom, we have x plus 2 squared plus 1. We don't have the square root of that stuff. So, secant squared theta equals x plus 2 squared plus 1. Excuse me, I forgot a dx. Goodness gracious. So, now we have our dx to plug in, and we have our x plus 2 squared plus 1. Let me just erase this so there's still room to see it. So, 1 over secant squared theta times our dx, secant squared theta, integral d theta. And you'll notice this is another one of those problems where both of them just cancel out, so we get the antiderivative of d theta, which is just theta, but you can't leave it as just theta because the problem gave it to you in terms of x, so you must have the answer in terms of x. So what we're going to do is we're going to solve backwards from here. X plus 2 equals tangent of theta. We're going to take the arctangent of both sides, which is going to be arctan of x plus 2 plus c. And that's going to be our answer. And that's how easy it is to evaluate integrals using trig substitution.